Okay. I'm alive. Okay. Okay. Oh, there you go. Hello. So, what we're going to do is, I think this is all right. Going to, so, as you might know, diffusion models are everywhere now, and there was a paper, I don't know when this was released, well, last month. So this paper is awesome. I was tinkering with it, but I want to know more on exactly how it works. So I'm going to do that. I'm going to take some notes, read this paper, and then we might tinker with the implementation or use it in some app. I think the automatic the Diffusion web UI has ControlNet already. I've used that in this a couple of days ago. So yeah, the idea is to read this paper and tinker with this. So I'm not going to read it out loud because I think that might be obnoxious. So I'm going to read it and take some notes in the right. Okay, let's go. The text might be a little bit small. Where do I? Here. Oh, that's too much. There you go. I think that's all right. Okay. Okay, this is a really nice note to take. We don't need a lot of data to train this model, only 50k, and obviously we can do with more data. With a small 50k data set, we can train to lower a little bit the music. There you go. Okay, so notes. Nice. I didn't do a thing that I do most of the time when reading papers, that I skim over the top to see all the things that it has, to have a picture and know where to go then. So let's do that now. I read the introduction. So most of the time I read the introduction and then do this scheme that I'm talking about. So we have the introduction here, some images. I've already seen those somewhere. This is pretty awesome, the way it follows the canny edge here. Okay, related work. Going to read that. Method. Here's all the math. ControlNet. Okay, that's great. Okay, big equation. This is a little too much for me, actually. Like I'm not really that interested in this, but in the how it works. because this, for me, it might take a lot of time to decipher and know what the fuck is going on. So yeah. Okay, I was checking something. Okay. Training. Pro training. Okay. Okay. Good. Okay, I was checking something. Some results that are always nice to see. Here we see the Kenny edges. The sketch, I think it is this one. This is awesome, man. It's going to be really, really helpful for diffusion stuff. Pose estimation. Look at the hands though, right? I mean, they are really good. Okay. Right. Yeah, there's a lot of... going to see that later. Okay. To try not to take hours on this, I put like an hour max of reading this. I don't know if you're going to get it. And then we might test something in the web UI. Okay, let's read the introduction. Okay, so basically introduces the problem here that we don't have large data sets for specific tasks, and that even though we can like control the diffusion process through procedural processes, and end-to-end learning is like a better approach for this, and using transfer learning, it aids to the problem of having less data and like computing also. Okay, I don't think there's much to note here. Take a look. This is images. Canny Edge. This is quite interesting because they say that they don't put anything in the prompt that is from the source image, only that is high quality, and from the Canny Edge the result is already made. That's nice. Let's see what else is here. Okay, I think here's an awesome thing. Can I I don't use Acrobat. I can highlight text. That's awesome. But we're going to note here that the architecture, I don't know how to spell architecture. Oh. This is awkward. There you go. No. So for what I'm gathering here is that we have two networks. The first network is locked and preserve the capabilities of the whole or the original diffusion. Then we have the trainable one, and that one is going to control the other. And this is the one that we're going to actually train. And it is it is connected with a setter convolution. I don't know what that is actually, but I'm going to maybe they explain it later. Then we have a couple of details. Convolution has weights with them. That okay. Maybe we know that. Nice. One K also. Okay. Okay, we don't need massive clusters to drain this. That is quite nice. I've drained the diffusion in a T4, so I can assess this. Okay. Usually I skim over this, so I'm going to do that. I'm going to read it a little bit fast, and if I see something interesting, I'm going to point it out. But yeah, most of the time it's a little bit redundant. If you have been reading a lot of papers, this is like the same always. So, let me see something. I think we're good. Okay. Okay, let's read this a little bit fast. Okay. I think this is worth noting. So here they're talking about hyper networks that sort of attaches a small network to a bigger one to alter the weight and have another thing. Alter the outputs of the original network. Then here they explain the zero convolution. I think what they are referring to that is that the convolution, the weights of the convolution are all zero, so the initialization of that is zero. That's really interesting. Instead of doing an initialization with Gaussian or other method, is all zero. I think that's what they're referring to. That's interesting. Okay. Now the diffusion probability model. I think this is the same. Yeah, okay. A little bit history. This is nice to read, but nothing new here. Also, nothing new. Text to image. The using clip. That's nice. Oh shoot! What did I do? I think I don't know how. When reading papers, like if you click on this, you can go back. So I need to like go up again. Okay, where you are. Your text to image, personalization, customization, and control of pre-trained diffusion models. Okay. Yeah. Okay. Oh shit. I think you have the notifications too high. Sorry about that. Okay. Okay. Nothing worth noting here about ControlNet. Sort of talks about the difference between image to image and the ControlNet sort of motive. And yeah, let's jump to. I want to know how ControlNet is working. Too much introduction. Let's go. All right, the method ControlNet. Okay. Let's skim this a little bit. Okay. Okay, so 3.1 is the bigger section here. Let's let's take a look. So I'm pausing here to the first statement. It says, ControlNet manipulates the input conditions of a neural network, block, so as to further control the overall behavior of an entire neural network. So it doesn't say diffusion, so it says whatever neural network. So for now, let's just keep reading and see how this is implemented with diffusion models, but this might be used for other networks as well. So that can be a good thing to look if you can, like, I don't know, control better other networks, like a unit or something like that. Well, the diffusion model is a unit, so yeah, you might be able to do this with other networks. Let's keep reading. Okay, nothing more here defines what is a network block, but this paragraph here, I really liked it. Let's give it a highlight and copy it here. Can I copy it? Okay, I don't know what is going on. Cannot copy it. I hate this program. Okay, let's control. I don't know how to type. Neural. I don't know what. Okay, let's go. Can you see that? Yes, you can. Okay. This one? Oh, yeah, okay. Interesting. So they give an example of a feature map. Here, for example, like you have your neural network block, and you give an input, and you have a Y from the result. So what they do is grab a copy of that, they block the original one, and they train the copy. They do this to preserve the original capabilities of the network and to not this word always escapes me. overfit. Okay, that was. They don't overfit on a small dataset. That's it. But that's really nice, really interesting. They don't say like this is only for diffusion. This can be implemented in anything, really. Okay, what was I? Oh man, the water makes me burp. Okay. Here they're explaining a little bit the zero convolution. So it is a 1 times y, 1 convolution with weight and bias initialized to 0. With I don't quite understand why they're using 2 instances here. Maybe because it's like one from here and then another from the output. I believe that is. C is the zero convolution to the to C, then they sum to the X. Zero convolution to the output. A sum here. Okay. So set of C is 0 for the first step. Then what is this? F. So X times this one is F itself. F. Okay. Oh, nice. So in the first training step, the trainable copy doesn't add anything to the logged one. So that's rather interesting. Okay, let's note thing because I think. Here the weight and bias are initialized to 0 for 2. I don't know why it doesn't work with Notion sometimes. There you go. Nice. So, yeah, what was I saying is that the first training step, yc is equal to y, and once yc is all this thingy here. Okay, so f is the feature map, z is the zero convolution, and here's the representation of all of that in the right. But in the first iteration of the training, yc is equal to y. So the result doesn't change anything in the first convolution, in the first training step. Then when the convolutions of the weights here change, then we are going to add in the output things, or subtract. It is subtract? I don't know. Okay, what is it says here? Oh shit, that is so loud. Sorry about that. There you go. Feature addition. Okay, going to do. Oh, doesn't work. There you go. Note. I think this figure is really interesting. Okay. Awesome. Let's see something here. Okay. We good. Question 2, 3, handicap. Oh, that's, yeah. Okay, let me think about this. So the way it works at first is that it's like it never existed. So when you train, you preserve all the functionality of the original one, and you only need to fine-tune. Yeah, okay, that's great. I don't know if you need to note something from here. No. Okay. Now let's go. They're going to talk about the grading calculation of the zero convolution. This may need a lot of careful reading. have something in my nose. Okay, not gonna lie. I didn't fully quite understand this. So for now, I'm going to pass it over because it might take me a lot of time to decipher. For what I understand that they're saying is that with zero convolutions, the gradient passes correctly, given that the input is non-zero. So I think that's the gist of this. So yeah, I might let's note that. Okay, awesome. Okay, let's see it now in the diffusion. Sometimes I hate this because this part, where does it connect? Where non-zero? Okay, this after this step we have this. Okay, where non-zero. Okay, so yeah, the zero convolution weights changes to add things to the other one. Okay. So this is the thing in diffusion, right? So here we have color. I think this is the unit that removes the noise, and we have prompt and time. I wonder if also the time encoder and the text encoder here are, I assume they are also blocked in the condition. One thing that I don't understand is they might comment on this, but looking at the thing here, they only connect to the decoder part, not the encoder. The encoder is the one that is encoder. The one is being transferred, and that might. Okay, I understand why they're doing this, because you don't want to modify the decoding, because the decoding might be alright. I don't know, but you are modifying because you are adding the features, but not to the encoder. Okay. +3, +3, 3. Okay. Let's continue reading then. Okay, in this part. Okay, explaining what is stable diffusion here. This explanation is really nice. Okay, so as well as stable diffusion uses encoder to have latent images, so the latent of the images. The ControlNet also needs this, and they use a tiny network. I don't know what that means. So maybe literally a tiny network. So they also train this. That's interesting. They don't use the original one. They use a train, well, one that is trained with the full model. Okay. Let's actually note this. here is stable diffusion. Okay, so yeah, basically that. When they train stable diffusion, the ControlNet architecture uses a tiny network similar to what stable diffusion is doing to have the latency of that images and have the same convolutions and match all perfectly. So yeah, 512 to 64 by 64. Okay, pretty nice. I don't quite fully understand one thing this here. Like the way we connect the controller is computational efficient. Since the original weights are locked, no grading computation on the original encoder is needed for training. Since the encoder. So yeah, that was my question here. Why they don't connect with this? They say that it's not needed for the gradients. So you're going to flow here, go because it's locked. Into flow here instead. Okay. It might take a little bit more thought. We're going to highlight this for later. But yeah, this essentially is good, but I don't understand fully why what they can do it, not why they are doing it. Okay. Awesome. So it is quite simple. The concept, and I really wonder if you can use this with other networks. Let's say you have a segmentation network that is working alright, but you add ControlNet to fine-tune exactly something, right? That would be really amazing, because I don't know, sometimes your networks are a little bit shitty and you don't know why, but when you need more control, you are ControlNet. That's it. This is interesting to research this line, I think. because for what I'm gathering, there's nothing stopping you from doing that. Okay, a little bit of training. Let's see what it says here. Okay. I don't know if I need to note something here. Basically, explain how Stable Diffusion is training. That it issues latent space, and that, yeah, the when diffusion model is trained, usually you drop 50% or you switch from giving the prompts and not giving the prompts, so it learns more semantic over the given image or input rather than following fully the prompt. This helps with I forgot, context, no, free guidance, something like that. Classify free guidance, there we go. This helps with that because you, well, a lot of applications there. That would be rather nice if you guys want to also do a stream talking about the first paper of diffusion or stable diffusion and chat about that. That would be cool to do a video on that. Maybe look at the code and see what is there. Improved training. Let's see. Let's take a look at this. Okay, interesting. So if you only connect the middle block and not all of these four, you have a 1.6 speed. Then you when you show reasonable results, you can connect them back. Okay, let's note that. Okay, so they make a comment on large scale training. I'm not that interested in this, so let's continue implementation. Okay, here I want to see the amount of data and the amount of time they trained. So let's see the Kenny Edge. So they used 3 million images. Okay, this one is a beast. Okay. Okay, this is in this line they use the previous checkpoint of the network and reduce about to a fourth the training time. That one is interesting to note, and well, it was maybe clear that it can be done, but nice that they specify here. Okay. Okay. Don't think this is good, but nothing too specific to note from here. Experiment settings. They use 20 steps. Use a default prompt. Use 3 types of prompt to test the models. No prompt, default prompt, and automatic prompt. Yeah, use blip. So if you haven't heard of blip, you can describe an image, and it works rather good. So and use a prompt. Okay, evaluation. This comparison are interesting to see. Why? Look that up. Okay, let's see some results from the beginning and analyze. We already saw those. Here are sketches. This is amazing. Look at that. Pretty good. Okay. Head edge. Okay. That's awesome. This one is really nice to like use your own like retrain this with your own segmentation dataset. Maybe you can use that for augmentation. A lot of ideas there. Oh, look at that. So if you don't give it anything, I think this is the default. Fantastic, fairly detailed. You can change it all, but the structure of the image is preserved. Okay, normal maps. Okay, image mid step. This the one week. This is such a flex. They like, oh, you use 2,000 GPU hours. We use less than a week. You use a large A100 cluster. We use a 3090, and like pretty good. I don't know what I choose. But both are pretty good. But yeah, these are not a lot of training. Really good. This is awesome. Imagine for animation or like manga and stuff. You can paint super fast. I don't know if artists will want that, but as a consumer, pretty colors are pretty colors. This one is really nice. Like you can in-paint and change things. I think PT is another training, an image-to-image training similar to pix-to-pix, and it doesn't work that great compared to ControlNet and Diffusion. Well, nothing compares to Diffusion really. Okay. Oh, this is the thing that I wanted to this is, they call Sudden Converge. So it's like an Apple Mac, an iPad, and then boom, you have exactly what you input. Damn. 3 million training steps. That's a lot. More examples. No, this was a fail, right? Yeah. Okay. Credit, and that's it. Okay. It only take me about an hour. Alright, go to the authors. I'm not going to say their name because I might butcher them. This is really nice. Now, I don't know what to do. I might try ControlNet with the web UI, or I can what's the thing? Can read the code, but it not might be that interesting. I don't know. Damn, 12,000 stars. That's crazy. Let's do a quick search of let's see. Okay, this might be dangerous. Okay. No. I don't think anyone did what I'm thinking. Maybe an interesting thing to do. Okay, I want to know. Let's read something here and see if they have the training here is the examples, but I want to see the training. Train with your own data, annotate your own data. Impressive script to process data. See great example here. Use ControlNet in any community S1X. Okay. Relate the resources. Training control is easy as simple pix to pix examples here. And another matter of things here. Yeah, there's a lot of code here. Models. Okay. Yeah. Okay. This might be interesting to look at. The person here is look, I think here's my doubt from earlier. No, I think this is other thing. Who is the? Oh, I think this is the author. Okay, I don't know if this is interesting to look now, but yeah, if you want, this is in the ControlNet repo. I'm going to read it after the stream. This is another thing. Okay. They might, I don't know, might be a little bit faster with a couple of considerations, but it is not proven yet. How do you save a thing here? I'm not logged in, so I can't. Okay. Let's see. Okay, awesome. Let's read this stuff. That is the training of ControlNet to control stable diffusion. Yeah, but also going to It's really interesting to make ControlNet to other networks. That would be really interesting to do. But yeah, let's see. No. Okay, this is a toy dataset. Design you control. Okay. So you need a target. Yeah, that is obvious. So you have a JSON. So you open the JSON, get the length and every item. You read this source on the target. Turn to RGB and normalize the data. And you give the JPEG, the text, and the hint. The hint is the source. Okay. What? Do not ask us why we use these three names. This is related to a dark history of a lyrical LDM. JPEG, text, and hint. I don't know what they're talking about. They give you a script to copy the checkpoints. That's nice. Diffusion 2, blah blah blah. Okay, the training. So grammar stagnate. Lightning. CLDM. This is the thing that they're talking about here. LDM? No? Logger, model, current model, stack date. What's that? The CLDM. CLDM. Or CLD. I think this is the same. What is CLDM? ControlNet, diffusion model, control diffusion model, logger model, create model loggers, PM training, trainer, I think it is. Here's CLDM. So here's the model. Interesting. So now this is ControlNet model. Here. We load only model. I'm in the wrong folder. Not going to enter the rabbit hole that is looking for what the heck this is doing, but essentially this is rather simple. They use PyTorch lighting, so I assume the model has all the logic from the training, and you only give it the data. So yeah. It reminds me that I need to look up PyTorch lighting and like learn it very well, because this is awesome. Like having all in the model itself, and like having the gradient accumulation and multi GPUs, accelerated dataset loading, etc. inside the PyTorch lighting class, and now having to do it yourself. It's pretty great. Like here, CPUs 1, like you can put 10 here. This is what they were talking about in the paper, like removing these 4 connections. If you log and need control, so you can need to know. False. Okay. Okay, you can pause and resume this how you like. This option is dangerous. This is a interesting note. If the generation is not good, the trading failed, because it's always capable of doing something. Okay. Talks about how specific of training, not that crazy here. Where are the let's see if we can load automatic sway UI and check out a little bit of this. Okay. need to download the models here. But what the heck they are? Okay. Okay. It is loading the web UI. If you want to know, you can. I think you can download the models here. I don't see them. It's in releases. Nope. But models. Nope. Okay. 5 gigabytes. That's a lot. I think you can. This page has the safety sensors that are a lot less. The weight. Shoot. This is not loading. Come on. Okay, I think let's do a sort of review of what we saw. So we only need 50K to train the model. That's good. The architecture has 2 copies of the diffusion network. I would say here of any network. One is locked and one is free in the training. The locked preserves the original capabilities of the network. The 2 networks are connected with 0 convolutions. The convolution weights and biases are 0 and referred to as 0 convolution. This is also a 1 times 1 convolution. ControlNet manipulates the input conditions of the neural network block so as to further control the overall behavior of an entire network. I think I copied this. In the first training step, the trainer copy doesn't add anything to the original. Nice. The figure that this is a nice figure. If the input is non-zero, the gain of the trainer copy is correctly calculated. When training stable diffusion, when training the stable diffusion, ControlNet uses a tiny network to have a length in images. Okay. Excuse me. We can connect only the middle block to speed up the training. Good idea. Super thing. Okay, awesome. this is great. I think we're definitely going to use ControlNet for something in the future. I'm preparing, I think, I don't know, I have some ideas in my mind about some projects that I want to do. So yeah, it would be nice to add this, trying my own thing. Do you know that you can now, like, Notion has AI? Let's see what you can do. Oh, let's create a social media post. Now, improve writing. Yeah. Okay, let's go. Holy shit, this is fast. Training neural networks can be a challenging task, but with ControlNet, it is made easier. By manipulating the input condition of neural network blocks, ControlNet can further control the overall behavior of an entire network. The architecture of ControlNet involves two copies of any network, one locked and one free in training. The locked copy preserves the original capabilities of the network. The two networks are connected with zero convolutions, and convolution weights and bias are initialized at zero, referred to as zero convolution. If the input is not zero, the training of the training copy is correctly calculated. When training is with diffusion, ControlNet uses a tiny network to have the linear of the images and have the same shapes. You can connect only the mirror. I should start from control to specifications underneath. With only 50k, we can train more to have excellent results. Damn, training with ControlNet. That's a really nice one. Like, maybe not that interesting in some point. Like, you can only connect the mailbox. Like, mailbox of what? Doesn't. Let's try again. Oh shit. Okay, dude. The ice. Oh shit. Dude. This AI has no chill, man. Has no chill. This is fun. Try again. Try again. Shit. Oh, I put a blog post. Okay, I have my blog post. Nice. I actually can post this on dev.to. I might change a couple of things to see if this is all correct and sound. Man, I'm going to restart the web UI because I want to show and, you know, experiment a little bit. This is not working. So, now networks are revolutionary field of machine learning have achieved remarkable results in various tasks, which are blah blah blah. Or designs, to control the overall behavior. This will discuss how ControlNet can be used to manipulate inputs and control of neural blocks, and thus control the behavior on the network. The architecture of ControlNet. So two copies on it. One looks and one is free in training. The copy preset the original with the copy manipulate input. We have now the two network connected with zero convolution and the convolution with bias to a zero convolution or one-on-one convolution. Okay. Training composition. In the first step, the training comp doesn't add anything to it. However, if the input is non-zero, the gradient of the training comp is correctly calculated. When training stable diffusion ControlNet, a tiny network is used to have the lineage of the image have the same color shapes. We can connect only the middle block to spread the train, and when we have reasonable result, we can connect the rest of the decoder layers. A good idea is to start from pre-trained control to specify something of our need. Conclusion. ControlNet provides a way to control the input conditions for network blocks and control the overall behavior of the network. The architecture of ControlNet consists of two copies of any network. One is locked and and the other is free in the training. During the training, the locked copy preserves the original capabilities of the network, while the training copy manipulates the input condition of the blocks. ControlNet can be used to speed up the training process and specify the requirements of the network. That's actually a really concise and nice blog post. But, like, here's my predicament, right? I did wrote the point, right? The AI helped me put it in a nice, concise and way. I don't know, man. It's like I think it's nice because I did spend how much time? Like an hour 15 minutes reading the paper, putting the bullet points of what I thought that was interesting to show, and then the AI say like, I got you, man. This is the post. Here we are. It's like a nice, it's like, okay, if you have a person, this is related to ControlNet. I'm ranting right now and talking about stuff. Like if you have a person, right, that you send the bullet points and say, okay, write me a post with this, and say okay, and it gives you this. Like that would be like seeing in a better light. But what you do with AI is sort of I don't know. I think this is a really good post. I might change a couple of things, add a couple of images, and I think I'm going to put it in my blog. That's awesome. Okay. Think the thing loaded. Okay. Let me take a look at something. Let's maybe maximize this. I can't. Okay. Now. Good enough. Here we have the ControlNet. ControlNet Canny. Okay, so if you don't know, you need to download SD Web UI ControlNet and get use it here in painting or whatever you want. Let's see. Let's try with. Okay, have an idea. Have an idea. Here it is. What is my thing? A Bugatti. Let's make it 712. Oh shit. Okay, doesn't matter. The Bugatti. 712, 720. No, it's 768. There you go. Spaceship from outer space. See if this works. Same here. Change the resolution. Generate. Hope the stream doesn't die. And if this works. Okay. We have okay, so we have the baseline. Nice. I forgot to enable ControlNet. Nice one. See if this all works. But yeah, going to tinker with this a little bit. We're going to end this stream. I might upload it entirely or make a shorter video. I don't know. If you see this point, let me know what you think, and I might do from time to time one. And this ain't working. I don't know. It says in the console that it loads tomorrow and all good, but it's not loading here. I don't know. I click interrupt, nothing happens. Click twice, and nothing works. It never works though, but what else? Okay, the magic button. Let's reload this. ControlNet enable. Okay, without prompt, let's see if this works. Doesn't seem to work. Oh, doing something. What happened? Stopped. Oh, shoot. I think the GPU doesn't like that I'm streaming at the same time that I'm doing this. Yeah, no, it's like, no man, can't do that. generate something. Come on. But look at that. I'm using realistic vision. This from CVDI. Really cool page to download models. This doesn't work. Okay, I think going to end it now. Had a lot of fun reading this paper, and I might do another one implementing this or fine-tuning the model or using this in any way. Hope you enjoyed it, and let me know if you reached this point. Please leave a comment, and that's it. That's it about myself. Gonna give it one last try, but I think it's not going to work in the queue. Yeah, I think I fucked it up. Fucked it up. Okay, everybody. Hopefully, I will see you in the next one. All right. Take care. Bye bye.